This is Mike Biel. I'm going to go over lab exercise 6, elastic stress wave propagation. For this lab, I did not have the same test article that was used on campus, and I was not using an oscilloscope. Instead, I was going to use LMS test lab hardware and software. And so I chose a non-metallic test article. I have a 4-foot section of nylon 6.6, and I selected this material based off of its properties. I did a little homework before selecting it. So it's got a relatively slower speed of sound in it compared to metal. So it will be easier to measure the stress wave propagation. So first is to install 2 gauges, one on each end of the 4-foot rod. And so I'm going to maximize the space between the two. The gauges were spaced 45 inches apart, so there's 1.5 inches from the center of each gauge to the end of the rod. I used a gauge that was suitable for aluminum. So I did not have any gauges that are suitable for nylon. However, there were no thermal transients expected during this measurement, so that should be a non-issue. So here's setting up the alignment marks to get the gauge on so it can measure strain in the axial direction. That's the direction of the stress wave that we want to measure. And so you can see on the right picture, there's a special tool that we have various diameters for that will fit over rods like this, so we can scribe marks on them easily. Okay, the gauges are now bonded or stuck to the tape, and they're ready to go to the test article. Here you can see the position. This gauge is 1 3/4 inches from the end. And I used 30 gauge lead wire, 3 conductor wire. The two gauges were connected in a 3-wire configuration. And after the lead wire is connected, that's what it looks like. Hypertronics connectors were installed to be connected to the LMS system. And then to make it a little more interesting, I also introduced a PCB impact hammer. It has a force transducer in it, so I could also observe when the hammer hits the rod. So that should be the first shock wave I see. If the first event I will see is actually the response from the load cell and the hammer. So this is the data acquisition hardware. Several positions of the rod were tried. I tried it in a vise like this. I tried it just bouncing off the floor without using the hammer. And I tried it laying horizontally on a table with the edge hanging over, with the tip of the rod hanging over the edge of the table. And I tried a couple of different hammer tips. The best one was the steel tip. The mass of the rod was measured because its density is needed. Instead of using a published density value, I measured it. Since I know the diameter and length, I can easily calculate the volume. So this was used then to experimentally determine the modulus of the test article. And here's the shock wave result. The black curve is the hammer. So we can see, looking at this time history, the first event is the hammer. And then a slight fraction of a second later is at the hammer end of the rod, the red strain curve. And then an appreciable duration later, the blue strain curve at the other end of the rod, at the response end of the rod, responds. And so over that 45-inch distance, I had a 645 microsecond delay.